Hello students, welcome to Narayan College online classes. So in the last class we have discussed up to the 33rd level 2. Now coming to the 34th question number 34. Clear? So the shape of IF5 and IF7 are respectively. Clear? Whenever they are asking shape means you have to first find out the hybridization. Hybridization means how many number of bond pairs and lone pairs are there. You already know how to calculate. Clear? So first I will write IF5 and IF7 you calculate. Clear? So because so many times we are discussing how to calculate this hybridization. Iodine, central atom is one. Iodine belongs to which group? Seventh group. Seventh group means how many electrons I have right? 7 electrons. And each fluorine need 1 electron to form a what is here? Sigma bond. So this is 2 electrons left that we will consider as a 1 lone pair. So how many bond pairs are there here? There are 5 bond pairs. Because 5 F is there, means iodine should form 5 bonds with the 5 fluorine, so 5 bond pairs. And how many lone pairs? 1 lone pair. Total of 6. 6 means what it is? sp3 d2. Clear one? But they are asking what is the shape. If it is 5 bond pairs, clear one? And 5 bond pairs are there, 1 lone pair is there. What is the actual shape here? And 5 bond pairs, 5 only, no? Yeah, 1, 2, 3, 4, 5. 5 bond pairs, 1 lone pairs. What is the shape of the molecule? Square pyramidal. The shape of the molecule, what it is here? Square pyramidal. Square pyramidal is the. But they have not given here. That is trigonal pyramidal they have given, not trigonal pyramidal. This is what is square pyramidal. IF7 means how we will get one. IF7. 7 electrons will be there here, and each fluorine need 1 electron to form a 1, 2, 3, 4, 5, 6, and 7. All are which one? Bond pairs, 7 bond pairs, and 0 lone pairs. 7 bond pairs and 0 lone pairs. Which one? Pentagonal bipyramidal. So option 1 is the correct one, but option 1 you just change that is square pyramidal. So, and if you know like this, I will not discuss again because I have given how to calculate the hybridization. Clear one? Next one. 35th question I have already discussed in the class, that is when we have discussed about the dipole moment. Clear one? So what is the 35? Question number 35. Dipole moment R. I already said it. For only diatomic molecule, as the electronegativity increases, automatically dipole moment increases. But for means polyatomic molecules, it is not correct always. Clear? That's why here I have given already the reason what it is. CH3Cl is greater than CH3F is greater than CH3Br is greater than CH3I. Because you have to take the dipole moment means charge into distance you have to calculate, and the charge of this molecule into distance will come, the product will come highest for the CH3Cl. I have already discussed that one. Clear? Now coming to the 36. This is answer is for 35. Option 1 is the correct one. Coming to the 36. Clear? Which of the following will have least dipole moment? You already know what is the least dipole moment. Carbon dioxide dipole moment, how much? 0. That will be the least, C double bond O. It is a linear molecule, so that's why dipole moment for this one is 0. So option 2 is the correct one. And coming to the 37. 37 also same question we have discussed it in the classroom, but again I will discuss. Clear one? The experimental value of the dipole moment of HCl is 1.03 dBi. The length of HCl bond is 1.275 angstrom. The percentage of ionic character is character in HCl is percentage of ionic character. I already mentioned formula how to calculate percentage of ionic character. Clear? So how we will calculate it here? Mu observed divided by mu calculated into 100. Mu observed they have already given. How much they have given? Mu value they have given 1.03 d they have given divide. So now you have to calculate dipole moment. Clear now? So you know how to calculate the dipole moment? Mu calculate is equal to dipole moment. What it is, man? Charge into distance. Charge into distance. You know, bond length they have given. Bond length means D. Bond length they have given. Q they have not given. Q you already know. So what is the charge? Because HCl. HCl means what it is, man? H plus and Cl minus. Clear one? H plus and Cl minus. H plus and Cl minus means what is the charge on this ions? Unit 1 only. 1 means, you know, what is the charge? This is 4.8 into 10 power minus 10 ESU. Clear one? So next, and the distance how much they have given? Distance they have given 1.275 angstrom they have given, and I will write here 10 power minus 8 centimeter. 1 angstrom is equal to 10 power minus 8 centimeter. So this is the mu calculated. What it is here? Mu calculated. Clear? Now, if you calculate the percentage, you know, I will write here 4.8 into 1.275 into 10 power minus 18, and I can write ESU into centimeter. Shall I write here? You know that 1 Debye value is equal to 10 power minus 18 ESU centimeter. Why? Because mu observed they have given in Debye, so that's why this should be also converted into the Debye. So 1 Debye is equal to 10 power minus 18 ESU. What it is here? Centimeter. So that's why mu calculated can be written as 4.8 into 1.275 into, instead of this, what I can write here? Debye. Clear? Shall I write that now? Yes, I can write. So now, if I do the calculation for this, see what is that one? 4.8 into 1.27. 4.8 into 1.275. Clear? So what is the value here? 6.12 divided. This is the value. Clear? Now what we have to calculate? Percentage of ionic character. What is the formula? Mu observed how much they have given? 1.03 divided by mu calculated. How much we got? 6.12 divided into what it is? 100 divided by get cancel. Then what you will get? You will get here 103 divided by 6.12%. Now you see if you calculate that 103 divided by 6.12. So clear, ma? So what is the value here is, you got 16 point, what it is here? 16.83%. What do you got here? 16.83%. Approximately you can take how much percentage? 17%. That is your answer. What is the answer here? Option 3 is the correct one. Next one. Coming to the 38. Question number 38. This is one of the important questions. The dipole moment of compound, this they have given. Clear? Cl is, for this one, dipole moment they have given 1.5 T. For this compound, dipole moment is 1.5 T. Next, they are asking what is the dipole moment for this compound. They have given Cl and Cl, clear, and Cl here, and next one is Cl here. For this one, what is the dipole moment they have given? Clear, no? You see now. For one fluorine, if it is there, what is the dipole moment here? 1.5 T. Clear? Now, for this one, what is the dipole moment? Now you know that the dipole moment direction for this molecule is upward, because this is carbon, this is chlorine. Chlorine is more alternative, dipole moment direction will be like this. For this one, dipole moment direction will be like this. For this one, dipole moment direction will be like this. But you see, in this case, for chlorine, this is dipole moment direction. For this one, dipole moment direction are exactly opposite and with the same magnitude. So that's why for this chlorine and chlorine, these are in para position. You know, these are in same position. Chlorine here, chlorine here. So dipole moment because of these two will be 0. Shall I write now here? Yes. So means I will not consider these two CLs because with these two CLs dipole moment is cancel each other. Then which are left here? This is left. What is left now here? This is left. What it is here? Chlorine, and here chlorine. Clear? Why I have written like this? Because these two are cancelled. I have given one formula. Whenever there are means more than one substituent on the benzene ring, how to calculate dipole moment, resultant dipole moment. I have given one formula. Clear? So resultant dipole moment will be is equal to how to calculate mu1 square plus mu2 square plus 2 into mu1 mu2 into cos theta. Have I given this formula? Have I given or not? Yes. But here chlorine and here also chlorine. This is dipole moment. Mu1 is for this one and mu2 is for this one. But mu1 is equal to mu2. Why not? Because both are which one? Chlorine atoms only. Shall I write here? So that's why I can write here mu1 is equal to mu2 is mu2 equal. So what can I write now? I will take as a mu these two. So here mu square plus this is also what it is now. Both are same. mu1 is equal to mu2. I have taken mu1 as a mu and this is also what it is now. Same mu square plus 2 into mu square because this is mu into mu. Then we will get what it is now. Cos theta. This is the formula. Then what I can get here? What I can get? You see here 2 mu square plus 2 mu square cos theta root over. Shall I write here 2 mu square I will take common. Then what I will write now? Cos 1 plus theta. Cos 1 plus theta, you already know what is the formula. Cos 1 plus theta is equal to 2 cos square theta by 2. This is 1 plus is there and here minus 1. This is the formula of 1 plus cos theta. What is the formula of 1 plus cos theta? 1 plus cos theta is equal to means here 2 cos square. Cos theta what I can write means here 2 cos square theta by 2 minus 1. Minus 1 can cancel. 1 plus cos theta means what I can write here 2 cos square theta by 2. That is only. So 2 cos square theta by 2. Then finally what I will get? 4 into mu square cos square theta by 2. Shall I write what this is resultant? So then what I can write here? I can write 2 mu cos theta by 2 whole square. This is what it is. Mu resultant. So what I can write simply here? Mu resultant is equal to 2 mu into cos theta by 2. This is the final formula. You have to remember. I have derived to understand how it has come. If both are same, then what is the resultant formula here? Mu r is equal to 2 mu into cos theta by 2. This is the formula you have to remember. Clear? So now, what you will get here? You see, mu resultant is equal to 2 into mu they have given for 1 chlorine 1.5. Clear? Mu they have given or not? Yeah. So that's why mu they have given for this benzene. How much? 1.5. And cos. What is the angle here? You see, dipole moment direction for this one is upward, and for this one here, and connect this somewhere they connect here. So what is the angle here? This is 60. This is how much, man? 120. That is clear, man? Cos 120 divided by what is here? 2. Then what will we get? 2 into 1.5 into cos 60. What is the cos 60, man? 1 by 2. So here 1 by 2 to get cancelled. So what will we get, man? 1.5d is the resultant dipole. Clear, man? So this is how to calculate. Just you have to remember what is the formula, and mu resultant is equal to 2 mu into cos theta by 2. Mu they have already given. Theta you know we can find out here. This is 120. Kept here. What do you get here? 1.5d. That is the question number 38. Next question number 39. Which of the following set of characteristics leads to increase in solubility of ionic substances? Means soluble, which one will increase? if high dipole moment, more will be the, dipole moment is used to measure the polarity. Greater the polarity, greater will be the solubility. Clear? So that's why they have given high dipole moment. High dipole moment means what? High polarity. High polarity means what? They can easily soluble in water. And another one is, what is the very important criteria for molecule to soluble in water? I have already given. Hybridization means hydration energy must be greater than the lattice energy. Means the molecule should have high hydration energy, then only those molecules will soluble easily. So option 1 is the correct one. Clear? And coming to the question number 40. Clear? Coming to the question number 40. Clear? The correct order of increasing S character in percentage in the hybridization of the following molecule. Means S character they are asking. You know how to calculate the S character. Suppose if you are getting sp3 hybridization, how to calculate S character? Total how many orbitals are there? 1 s orbital and 3 p orbital. Total 4 orbital. How many s orbitals are there? 1 into 100. That is what it is, percentage of S character. Like that you have to calculate. Clear? So you know how to calculate here hybridization. Calculate by using our trick. We have trick and do that one. I will just do that for 1 or 2 molecules and remaining you do. Clear? See now. What is that one? I will write CO3 2 minus. What is my here? CO3 2 minus. CO3 2 minus. What is the central atom here? Carbon. Carbon belongs to 4th group. How many electrons I have to write? 4 electrons. And here 2 minus means I have to add 2 more electrons. Minus means add. Plus means subtract. So oxygen, each oxygen needs 2 electrons to form a one is sigma bond and another one is pi bond. So this is sigma bond and remaining it will form pi bond. But you know that pi bond, because oxygen will give 2 electrons and carbon should give 2 electrons to form a 2 bonds. One is a sigma bond and another one is a pi bond. Clear? So that's why. But calculation and hybridization, we never consider the pi bonds. Clear? We will consider only sigma bonds. So those we will consider as a bond pairs. How many sigma bonds are there? 3. 3 sigma bonds are there means how many bond pairs? 3 bond pairs. Is there any lone pair? No, 0. So that's why total how much? 3. 3 means what it is? sp2. sp2 means how to calculate the S character. Total 3 are there. 1 by 3 into 100. This is percentage of what it is? S character. Clear? In that way you have to calculate. Next one. I will do the second one. I3 minus. Remaining you do. Clear? I am giving like this is as a one. I3 minus means what is the central atom here? I only. Clear? One I will be like this. Another one I will be like this. This is I minus. I3 minus. What is the central atom here? Iodine. Iodine means how many electrons you have to write? Iodine belongs to 7th group. So 1, 2, 3, 4, 5, 6, 7. But minus is there. 1 electron you add. And here how many iodines are attached to the central atom? 2. 1 iodine here. 1 iodine here. Clear? Remaining all are which one here? Remaining all are lone pairs. How many bond pairs are there? 2 bond pairs. And how many lone pairs are there? 3 lone pairs. Totally how much here? 5. 5 means what is sp3. What is the S character here? S character how to calculate? Percentage of S character. Total how many orbitals are there? 1, 2 means here 1 plus 3, 4, 4 plus 1. 5 orbitals total are there. Divided by 5. How many S orbital? 1 into 100. Then calculate percentage here. 20% S character. Like that you have to calculate. Remaining molecules also you calculate and you see which is having the highest. What it is here? S character. But if you do, you should get option 1 is the correct one. Next one. Coming to the question number. Let's see the part 1. The bond angle in pH3 means they are comparing bond angle between the pH3 and NH3. pH3 and what it is here? NH3. You know what is the shape of this molecule? Pyramidal shape hota. Clear? Ammonia. So this is ammonia. Ammonia and ammonia, there will be a one bond pair. Same phosphine also, because both are having, same group. This is clear. So now they are asking which one will have, means phosphine have a low boiling point, a low bond angle, or high bond angle compared to the NH3. You have to see. Now nitrogen and phosphorus. Clear? Nitrogen and phosphorus. Which one is more electronegative? Nitrogen is more electronegative than the phosphorus, because nitrogen and phosphorus are actually candidate bismuth. As we are moving down, electronegativity decreases. So that's why nitrogen is more electronegative than which one here? Phosphorus. So that's why, or you can say nitrogen is more electronegative than which one? Hydrogen. So these bond electrons are very close to what it is here? Nitrogen. Very close to what it is here? Nitrogen. When they are very close to nitrogen, and distance between these bond pair electrons are small. So that's why they experience here. I will take this is the bond angle, right? This is the bond angle. Or you can take these two also. This is the bond angle. Now I am talking about these two only. When nitrogen is a highly electronegative atom. So that's why when highly electronegative atom is there, the bond pair of electrons are almost close to that highly electronegative atom. That is here what is nitrogen. So when they are coming close, then what will happen here? The distance between these bond pair electrons are less. So they experience more or maximum repulsions. When they experience maximum repulsions, to avoid that repulsions, the two bonds will move away from each other. If they move away from each other, distance between the pair of bond pair electrons increases, so repulsions decreases. So to avoid this repulsion, and this bond will move this side and this bond will move this side, then what will happen? Bonds are moving away from each other, then bond angle increases. Clear here? But if you take here phosphine, if you take this is phosphine, we will call. This is what it is here, phosphine. Hydrogen and phosphorus. Phosphorus and hydrogen. Phosphorus only more electronegative, but these electrons are not that much close to what it is here, phosphorus. So it is close, but not this much close, because nitrogen, phosphorus is less electronegative. So that's why here. So compared to here what happened? The distance is somewhat large compared to here. Clear? Then what will happen? Repulsions will be somewhat less. So they also move, but very slightly they move. If you experience more repulsions, they move away from each other. But here they experience, because these electrons are not that much close to phosphorus. Here almost close, but here somewhere here. So if they are away from the central atom, repulsions will be less. Repulsion will be less, and automatically what will happen? Compared to here they move away from each other, but not that much. So that's why here bond angle is greater and here bond angle is less. Here what is the bond angle? 107 degree. But here the bond angle is 93 degree. Clear? So that's why as the central atom electronegativity increases, bond angle increases. Compared to which one? Surrounding atom. So that's why your option should be so much lesser than NH3, because it is 107, then it is 93. Option 1 is the correct one. The ratio of sigma bonds and pi bonds in benzene is, you can do, and benzene structure you write, and this is the benzene. Calculate how many number of sigma bonds are there and how many number of pi bonds are there, and do the sigma bond divided by pi bond ratio. You do, you will get the answer. Clear here? So calculate that, you will get. See, that here 6 bonds are there, and these are single bond. 1, 2, 3, 4, 5, 6. 6 plus 6, 12. But how many pi bonds are there? These are sigma bonds. Pi bonds are 3. So what is the sigma by pi ratio? 12 by 3. That is 4. Your option should be 3. Clear? Next one. Hydration of ionic compounds involved. Hydration of ionic compound. I already said what is the hydration energy. Whenever ions will be there, water molecule and make attractions between the ions and water molecule during that process, energy is released, and that energy we will call as a hydration energy. Previous I mentioned. And the hydration of ionic compound involves evolution of heat. Heat will be released. Correct only. A weakening of attraction forces of ions. Yes, you know, suppose NaCl is there, Na plus and what it is, Cl minus, and it is positive and it is negative. There will be some attractions. But if hydration is there, then what will happen here? You see Na plus, and you know oxygen will get negative charge. Clear? So these are hydrogen and hydrogen negative charge, and here there will be a hydrogen and hydrogen. This is hydrogen negative charge. Oxygens will have which charge? Positive charge. And so if you do this, then what will happen? You see, and the negative charge is there. Negative and positive, there will be some attractions, and due to these attractions, stability increases. Stability increases means what is one? Energy will releases. Energy will releases, and that energy during this process, energy will be released. That energy we will call hydration energy. Now, if you take Cl minus, which one will be here? It will form level and bonds with attraction because they are positive and they are positive. And here also I will write there will be a positive and positive. And here hydrogen water molecule here positive. Clear here? So there will be some attractions, positive and negative attractions. Clear? So this is due to this hydration. You see, attraction forces between Na plus and Cl minus ion decreases before there is no hydration. There is no water molecule here near to the Na plus and Cl minus. Positive and negative, there will be some attractions. But here and around the Na plus and around the Cl minus, water molecules will be there. So between these two, attractions become less. Clear? So that is what it is here. Weakening of attraction forces of ion due to the hydration. Ions attractive forces will weakening decreases. Dissociation into ions. Yes, the dissociation into ions. So all of these. So option is all of these. Clear? Next one. Coming to the question number 44. Clear? So if you take the question number, I will write here 44. Question number 44. They are asking BH4 minus what is the bond angle? What is the bond angle? You know, bond angle means first of all you have to calculate the hybridization. If you calculate hybridization, you can easily identify what is the bond angle. Boron belongs to which group? Third group. I have to write 3 electrons, but negative 4 electrons. Each hydrogen need one electron from the boron to form a 4 bonds. How many bond pairs are there? 4 bond pairs. There are no lone pairs, 0 lone pair. So what it is? 4 means what is the hybridization? sp3. You know, if there is no lone pair and the hybridization is sp3, then what should be the bond angle? The bond angle is 109 degree, 28 minutes. This is the answer. So approximately you can take 109. Clear? So which of the following species are hypervalent? Which of the following species are what it is? Hypervalent. Hypervalent means what it is? More than octet. What it is here? More than octet. And which atoms are more than octet? They are phosphate. Clear? So you know that in this one we have 4 options they have given, and you know one is ClO4 minus. Clear? ClO4 minus, and we have 3 SO4 2 minus, CO3 2 minus. If you write the structures, we can easily identify ClO4 minus. Clear? So ClO4 minus means this is the structure. Double bond O, double bond O, and double bond O. Chlorine belongs to which group? 7th group. 7th group means chlorine should form maximum how many bonds? 7 bonds it can form. So that's why, and we have 4 oxygens. Each oxygen should be bonded with the 2, means a bond between the carbon and chlorine and oxygen. It's simple. Oxygen forms 2 bonds. I have written 2 bonds here. So why I have not written here double bond here? If I write double bond, chlorine oxygen means around the chlorine how many bonds will be there? 8. Chlorine cannot form more than 7 bonds. it exceeds its valency. So that's why. And here I have to write here one. When oxygen is forming one bond, actually oxygen has to form how many bonds? Two bonds. Less than two bonds means which charge you have to put? Negative charge. That is only. Clear? Now you see what is the valency here? Hypervalent. Clear? 8 bonds means 8 or 4 bonds are there. 4 bonds means 8 electrons. That is octant. Greater than 4 bonds, that is hypervalent. Clear? See now, here how many bonds are there? 1, this is 1, 2, 3, 4, 5, 6, 7. 7 into 2, how much? 14 electrons are there. What is the octant? Octant means how many electrons should be there? 8 electrons. So it is, what is my hypervalent? More than 8 electrons means hyper, what is my valent? So that's why that's our code. BF3 we have discussed so many times. This is BF3. How many electrons, how many bonds are there? 6. 3 bonds. 3 bonds means what is how many electrons? 6 electrons. It is less than what it is here? 8 electron. It is not a hypervalent, a hypovalent it is. Clear matters? That is. Next one. SO4 2 minus. Sulfur belongs to which group? Sulfur belongs to 6 group. Maximum how many bonds it can form? 6 bonds. And so that's why 2 bonds here and O minus and here O minus. Clearly 6 bonds are there or not? I should not put here O and O double bond. If I put here 8 bonds, sulfur cannot form 8 bonds. Clear? Maximum bonds is equal to its group number. That is only the maximum sulfur can form 6 bonds, not more than 6. So this is how many bonds? 1, 2, 3, 4, 5, 6. 6 bonds means how many electrons? All electron exceeds octant, so that's why it is a hypervalent. Clear? So like that. CO3 2 minus. CO3 2 minus we have discussed previous only. This is O minus and O minus. How many bonds are there? 4. 4 means it is octant only. Clear? So this is what it is here, hypervalent. 1 and 3 are shows the which one hypervalent. So next one is NEET questions previous. AIPM and NEET questions are there. See the first question. So in which one of the following species the central atom has type of hybridization which is not same as the present in other 3? Simple question they are asking. And which compound has a different hybridization? Which compound has what is different hybridization? You know how to calculate the hybrid. I will not discuss which we have already covered. So which we have to cover, that I will discuss. Clear? So now you know here in this case what you have to do. You have to find out the what it is here hybridization. SbCl5 they have given. So first question. SbCl5 2 minus. Sb means where it will come? Nitrogen, phosphorus, arsenic, antimony and bismuth. This Sb belongs to 50 group. Sb belongs to which group here? 50 group. 50 group means 5 electrons you write. And 2 minus means add 2 electrons and calculate hybridization. Remaining 4 you calculate hybridization, which is coming different, that will be the answer. Clear? Good. Next one. Second question. Question number 2. Which of the following species does not exist under normal condition? Clear? So this is important. Which one molecule? They have given 4 molecule here. Which is not existed? See, they have given the first one is Be plus 2 and what is Be 2 and B2 and here Li 2. Which one is not existed? Whenever they have given question like which one is not existed, you have to calculate the bond order. Clear? I already said, if bond order is positive, molecule is stable and exists. If bond order is 0 or negative, clear? And those molecules does not exist. I have given already those points. Clear? So what you have to do here? You have to calculate the bond order. Clear? So you know how to calculate the bond order. Bond order is equal to, because I have given simple trick for 8 to 14 electrons and 15 to 20 electrons, but they are coming below the 8 only. Easily we can calculate bond order. Here beryllium. Clear? So beryllium will have how many electrons? You know, first one hydrogen, helium, lithium, beryllium. Beryllium will have 4 electrons, but beryllium 2 they have given or beryllium they have given. They have given Be plus 2. Clear? Be plus 2 means actually they have to give here. I think Be2 plus 2 they have to give because molecule they have to give. So 4 electrons are there. 4 into 2. Each one will have 4 electrons. But beryllium 2 are there. 8 electrons. 8 and plus 2 means you have to remove 2 electrons. Total how many electrons are there, man? Total electrons here 8 minus 2. 6. 6 means what we have to write? First sigma 1s2 and sigma star 1s2 and sigma 2s2. These are only 6 electrons. Now calculate bond order. Bond order is equal to half into Nb minus Na. So you know that here half. Nb means this one is this one. Stars are not there. Those are bonding molecular orbitals. So that is 2 electrons here, 2 electrons, 4. 4 here how many? Anti-bonding star. 2 electrons are there. So here 2 by 2, 1. 1 means the bond order is 1. Bond order is 1 means the molecule exists. But if you go for Be2 means how many electrons? Total number of electrons. Total number of electrons. How many? 8. Total number of electrons how many? 8. You know that how to write here. Sigma 1s2, sigma star 1s2, sigma 2s2 and sigma star 2s2. This is total 8 electrons are there now. Bond order you calculate and half into bonding molecular orbitals. 1, 2 means here this is 2 electrons, here 2 electrons, 4. Anti-bonding star, here star, 2 electrons, 2 electrons. 4 minus 4, 0. 0 by 2 hours, 0. Means bond order 0 means this molecule does not exist. That is the answer. Clear? So if you calculate remaining, you will not get the bond order 0. So what should be your answer here? Option 2 is the correct one. So remember one thing, whenever they are asking which molecule, which of the following molecule does not exist means what you have to find out the bond order. Clear? That is. Next one. And the correct order of increasing bond angle in the following molecules. They have given 4 molecules here. They are asking bond order. What is this one here? Cl2O they have given, and another one is Cl2O they have given, and ClO2 minus they have given. Clear? Again, this we will discuss in the second year. Halogens are there. There we will discuss. But just I am giving one simple. So if you take here Cl2O, what is the Cl2O? And chlorine oxygen here, and chlorine. This is Cl2. Clear? If you write here, sorry, 2 times I have written Cl2, and this may be Cl2. Clear? So whenever Cl2 means double bond O and double bond O, here there will be 2 electrons, here 1 unpaired electron will be there. Clear? So if you take this is Cl2, double bond O, and here O. Simple, you see. What is the central atom here? Chlorine. Chlorine means how many electrons we have to write here? 7 electrons. 1, 2, 3, 4, 5, 6, 7. Oxygen forms how many bonds here? 2 bonds. 2 electrons. Means 1 sigma 1 pi, 1 sigma 1 pi. Here 1 lone pair, this is 1 lone pair, another one is free electron, single electron. This is, unpaired means single electron molecule. This is clear. It will have single electron. But here if you take Cl2 minus, it is Cl2 minus means what it is, man? We can put here Cl2 minus. Cl2 minus means another molecule will come here. So this is clear. So in this case, you will have what it is going here. How many lone pairs will be there? So 2 only. So 2 lone pairs will be there. That I have clear. So these are the pictures. What are we making? See, this is the compound. Cl2 minus. Or otherwise, you can write double bond and here minus 1. No problem. Clear here? Now, what is the bond angle you have to see? Lone pair here, double bond is there. Double bond pair, and here double bond, or you can simply say double bond almost is equal to lone pair. Repulsions is equal to, it is greater than lone pair. Bond pair is greater than bond pair and bond pair. This is the actual atom. We have studied up to here, but now this is new answer. Clear? Here, double bond. There will be a much repulsion here. Here also there will be a much repulsion. So these two bonds will try to move away from each other. When they are moving away from each other, but here you see, it is bond pair, repulsions will be there between. Then these bond electrons move towards here, away from each other. But here you know that again what you will get here. You will get bond pair and lone pair repulsions here again. Got my point? But here also, when it is coming, you will experience here bond pair, lone pair. Clear? Where you will have greater angle? Here. Why? In this case, and their bonds are moving away from each other, but it is opposite by only one lone pair. If it is moving away from each other, opposite by which one, Mahia? Two lone pairs here. Opposite means they will not move much away from each other. So here bond angle less compared to here. Means which one will have highest? ClO2 will have highest. Clear? Compare now these two. If you compare these two, clear? I already said. Here chlorine, here oxygen. Oxygen is more electronegative. More electronegative means these bond electrons are much towards the oxygen. Then repulsions will be there here because they are very close to each other. To avoid this repulsion, these two bonds will move away from each other. And also here chlorines are there, very bigger one. And here also repulsions will be there. So in this case, somewhat. Here also what is known? There are two lone pairs. Clear? Here two lone pairs, here two lone pairs, but here one lone pair only. So it will have IS. In this case, here also when it move and when it move opposite by lone pair. But here opposite by lone pair, but also there will be repulsions. More repulsions here, so that's why there will be a more bond angle. So next you will get Cl2O and last one what it is? Cl2. This is the bond for your. That is option 4 is the next one. See the fourth question. In which of the following pair molecules central atom has sp2 hybridization? I need not to discuss again and again how to means simple. You calculate the hybridization for the central atom, which is for which pair it is having sp2 hybridization. That will be your answer. Clear? Good. Next one. Among the following elements and increasing atomic weight. Actually, this question should not be asked here. It is belongs to periodic table. Clear? So what they have given? Question number 5. You see, question number 5. Calcium, magnesium, and phosphorus and chlorine. Clear? You know that in this case, first one, second group, magnesium, calcium. After magnesium, you will get your aluminum, and after that phosphorus. This will come in the second group, second period. Clear, my dear? So now, if you see in this case, they are asking atomic size. You know, this is a period and this is a group. When you are moving along the group, you know, size increases. So that's why among these three, so it will have the calcium will have large size. Clear? Now, you have to see among these three. If you are moving across the period from the left to right, what will happen? Size decreases. Groups increases, periods decreases. So that's why next which one will have magnesium, after that which one will have phosphorus, and after that which one will have chlorine. That is the order. If you are moving across the period and from left to right, if you move, then what you will get here? Size decreases. Along the group, size increases. Clear? That is your answer. So option 2 is the correct one. Clear? Sixth question. Among the following, which has highest cation to anion size ratio? Simple question. Clear? So you know the cation to anion size ratio. Cation should be large, anion should be small, then the ratio will be highest. Clear? So which cation means you know, one is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So cesium is having, you know, large size and fluorine is having small size. So between these two, cation is having large size, anion is small size, then the ratio will be highest. So that's why option 2 is the correct one. Clear? Good. Next one, seventh question.
In which of the following molecule the central atom does not have sp3 hybridization? Clear? You already know how to calculate hybridization. You just calculate and see. The option should be 7th one, option 2. Clear? Next one. Question number 8. Question number 8. How many bridged oxygen atoms are present in P4O10? This is also irrelevant question. It will come in the second year. P4O10. Clear? So what is the shape of this molecule is? This is you will study very important. This is in the second year for the PU examination. Clear? Very important. This is the shape of the molecule. Clear? Double bond O and double bond O and double bond O, and here this is the actual structure. Clear? How many and bridging oxygen atoms are there? Bridging means between these two are there. This is the bridging. The bridge between the what it is? Phosphorus and phosphorus. 1, 2, 3, 4, and this is 5, and this is what it is? 6. Total how many are there here? 6 are there. So that you will study in the second year. 9th question. Some of the properties of the two species. One is, so 9th question. One is NO3 minus, and the second one is H3O plus are described below. Which one of them is correct? Clear? So simple. All they have given between the what it is here, hybridization they have given. Clear? Hybridization means calculate hybridization. You will get the answer. Clear? That is option 1 is correct. Different in hybridization of the central atom with different structure. If hybridization is different, automatically the structure or shape of the molecule also different. Clear? So option 9, 1 will be the answer. Clear? Option 1 is the correct one. 10th one. So consider the state of hybridization of carbon atom. Find out molecule among which is linear. Actually, option they have given wrong. The first one is CH3, CH. Just correct this one. CH and CH3. Second one they have given, it is CH3 and C triple bond CCH. This should be the triple bond. They have given in the option double bond. Triple bond means what is the hybridization one? sp. Double bond means what is the hybridization one? sp2. Single bond means what is the hybridization one? sp3. If sp is there, the molecule should be which one? Linear. Hybridization is sp. sp hybridization linear. sp2 and trigonal planar. sp3 tetrahedral. Clear? So which one is having linear shape means which molecule is having sp hybridization, that is only that molecule will have the linear shape. So this is about what is one here. Question number 10. Which of the following compound have lowest melting point? Clear? So which of the following compound have lowest melting point? Lowest melting point means what it is, Maya? The bond is weak, means lattice energy and melting point, boiling point or melting point is directly proportional. If bond is strong, you have to supply a lot of energy to break that one, and that indicates the high melting point. Clear? If you supply a lot of heat energy, then what it is, if it means at that high temperature, if it is means melts, that we will call as a melting point. Clear? So that's why and one here melting point is directly proportional to lattice energy. What it is one here? Lattice energy. Lattice energy means what? Lattice energy depends upon what it is? Bond strength. If bond is very strong and lattice energy will be very high, means to break that bond you have to supply a lot of energy, that we will call as a lattice energy. Lattice energy is high and you have to supply a lot of temperature to break those bonds. Clear? But I already discussed lattice energy. Lattice energy is very high for the small molecule. Small cation, if small cation and small anion is there, and for that molecules, what it is here, lattice energy will be very, very high. So that's why in all cases calcium is there, and this is calcium, and suppose calcium size is there and fluorine size will be like this. Clear? So this is both are what is the same size. Means almost we can say. Yes, suppose here calcium
iodine is there. Iodine size is what it is. This is. So what will happen here? Bond length increases. Bond length increases means we can easily break this bond, but here bond we cannot easily break. So that's why both calcium is in everywhere common. Now you have to see halogens. Which halogen here? Fluorine they have given. Fluorine, bromine and iodine. Which one is the small? Fluorine will be small. If small the anion, higher will be the lattice energy. If higher will be the lattice energy and greater will be the melting points. Why I have not considered here calcium? Calcium is there in all options. You cation you need not to consider here. You have to consider here anion. Which one is anion here? F minus, Cl minus, Br minus and I minus. Which one will have small size? F minus. F minus small size means it will have high. What it is here? Lattice energy. So melting point will be very high. Clear ma? Next one. Question number 12. Question number 12 Rr they have given. You already know. So what is the bond length here? C single bond C is greater compared to C single bond O and greater. This is double bond and last greater will be high. This is the bond length Rr. You have to remember this Rr. So next question is question number 14. Clear ma? 13th question, it is irrelevant because and here they have given plus 2 stability of plus 2 oxidation state. Actually we have to decide that one by using reduction potential, standard reduction potential that we will study in the electrochemistry chapter in the second year. Clear ma it is? So just leave that one. 14th one easy you can do. Which of the following ion list given below have geometry that is explained by same hybridization of argon? Means you find out they have given two compounds. You see the hybridization which are having the same number of bond pair and lone pairs. Clear ma? Means same hybridization. Means same hybridization, same number of bond pair and lone pair, and you know how to calculate that. Clear ma? Good. Next 15th one. You just calculate the hybridization. Same hybridization which compounds are getting, and that will be the answer. Clear ma? Next one. 15th one. Which of the following has minimum bond length? Which of the following has minimum bond length? Minimum bond length means I already said when they are asking bond length, you have to calculate what it is ma? Bond order. Bond order is inversely proportional to bond length. So calculate one by one. First one what they have given ma? O2 means you already need not to calculate oxygen because you know oxygen between oxygen which bond will be there? Double bond will be there. So what is the bond order here? Bond order is 2. Next the second one what they have given ma? O2 plus 1. O2 plus 1 means oxygen totally. Oxygen 8 electrons. 8 into 8 16. Plus 1 means minus 1 15. So 15 electrons are there. What is the bond order formula? 20 minus n means 15 divided by 2, so 5 by 2. 5 by 2 means how much? 2.5. Next one, O2 minus. Next one is what is O2 minus. O2 means 16 electron. Minus 1 means you have to add 1 electron. Total 70 electron. What is the bond order? 20 minus 17 divided by 2, 3 by 2. 3 by 2 means what is 1.5. And fourth one is O2 2 minus. O2 2 minus means what? 16 plus 2, 18. What is the bond order here? Bond order is equal to 20 minus 18 divided by 2. 20 minus 18 divided by 2, 2 by 1. Means which is having highest bond order? That will have the minimum bond length. So they are asking minimum bond length means which one is having highest bond order here? 2.5. O2 plus 1. O2 plus 1 is having the highest bond order, so it will have minimum bond. So option 2 is correct. So which of the following is isostructural? Very important. Whenever 16th question you see, whenever they have mentioned isostructural, when they will give isostructural, when the molecule will have isostructural means if the molecule has same number of bond pairs and lone pairs. Bond pairs and what is here? Lone pairs, and that molecule will have the
same structure, and that we will call as a isostructural. Clear one? So now if you calculate here, first I will directly calculate second option. You see BF4 minus and another one is NH4 plus. Boron, you know, third group, so I have to write the 3 electrons, and you know 1 minus means 1 electrons I have to add, so 4. Each fluorine need 1 electron. How many bond pairs are there now? 4 bond pairs. Is there any lone pair? 0 lone pair. Here also nitrogen belongs to 50th group. I have to write 5 electrons, but plus 1 is there 1 electron I have to remove. Each hydrogen need 1 electron from the nitrogen to form a, what is here, bond pairs here, 0 lone pairs. 4 bond pairs and 0 lone pairs. So sp3 hybridization, here also sp3 hybridization. 4 bond pairs and 0 lone pairs, tetrahedral. And here also what you will get, man? Tetrahedral. So whenever important this is tetrahedral. What is it here? Tetrahedral shape. Whenever means same structures both molecule have, that we will call as a isostructural. Means whenever they are giving isostructural, then what you have to find out? You have to find out number of, means which molecule. First you find out the bond pairs and lone pair. Which molecules have same number of bond pairs and lone pairs, and those molecules will have the same structure, and those molecules we will call as a isostructural. So option 2 is the correct one. Remaining also, for remaining molecules you can calculate. Clear? This is what it is here. Question number 16. In the question number 16, if you wanted to calculate in the second option, this is, I have mentioned first option. You see, what is the first option they have given? First option NF3, BF3. See, both will have the same structures or not. Once you check it, nitrogen belongs to 5th group. Each fluorine required 1 electron from the nitrogen to form. So how many bond pairs are there? 3 bond pairs. And how many lone pair is there? 1 lone pair. So total what it is, sp3 hybridization. 4 will come sp3. But here boron belongs to third group. Each boron need 1 electron. So how many bond pairs are there? 3 bond pairs. 0 lone pair. You see, bond pairs 3, lone pair 1, 0. That's why these two will not have the same structure. 3 plus 1, 3 bond pairs and 1 lone pair. Here sp2 hybridization. What is the shape, pyramidal shape. It is pyramidal shape. And here boron means 3 bond pairs, 0 lone pair. What is the shape? The shape is trigonal planar. That's why I mentioned here, if molecules have same number of bond pairs and lone pairs, then those molecules will have the same structure. Clear one? That structure we will call as a isostructure. Clear? That is 16th one. So remaining 3 also you can calculate. So which of the following species contains 3 bond pair, 1 lone pair around the central atom? Simple question. 3 bond pairs, 1 lone pair. Once you calculate, clear one? So calculate where the bond pair and where the 3 bond pairs and where the 1 lone pair is coming, you can easily identify. Means, you see, for this one also simple trick is there. One is there, first one, NH2 minus, and second one, what they have given here? PCl 3, and the third one what they have given? H2, and fourth one what they have given here? BF3. Means 3 bond pairs means, you know bond pairs means what? If 3 bonds are there, we will call it is a 3 bond pairs. Here you see, how many bonds are there? 3 bonds are there, 3 bond pairs. Here also you see, around the nitrogen, how many hydrogens are there? 2 hydrogens. 2 hydrogens means we will consider 2 bond pairs only, because nitrogen, this is, how many bonds are there? 2 bonds, so 2 bond pairs. Here how many bond pairs are there? Means how many bonds will be there? Phosphorus will form 3 bonds with the chlorine PCl3, means Cl. How many bonds are there? 3 bonds. Means how many bond pairs? 3 bond pairs. Here how many bond pairs? Oxygen and oxygen, 2 bond pairs here. But here how many bond pairs? And 3 bond pairs here, because boron, F and F. Boron is forming 3 bonds with the 3 fluorine, 3 bond pair. Means simply we can say first one and third one is not the answer. Answer is there between what is PCl3 and BF3. BF3 just now only I mentioned here. 3 bond pairs, 0 lone pair. So it is not the answer. So answer should be this. That is. In that way also you can say. How many bonds are there? That is the bond pairs we will consider. Clear, man? So question number 18. The pair of species with same bond order. Same bond order they are asking. You know how to calculate the bond order. I have given already simple trick. You use that one, you will get the clarity. Clear, my dear? So, and if it is electrons are greater than 8, I have given 8 to 14. What is the bond order? Everything I have given. Just what you need to do is just count the number of electrons. See whether the number of electrons are in between 8 to 14, then you use the formula bond order is equal to n minus 8 divided by 2. If greater than 14 means 15 to 20 are there, use the bond formula 20 minus n divided by 2. Then you will get the answer. Clear, ma? Next one. So bond order of 1.5 is shown by previous only we have discussed. What it is, ma? O2 minus is having, I already mentioned, O2 we have discussed. How much more bond order? 2 and O2 plus 1 we have discussed. Bond order is how much we got? 2.5 and O2 minus bond order we got 1.5 and O2 2 minus bond order we got 1. Clear? So this is order. Means what is the order here? O2 plus. Clear? Next what you will get? O2 minus and O2 minus 2. This is 2.5, 2, 1.5, 1. So which one is having now? Bond order 1.5. O2 minus we have the bond order 1 to 1.5. Clear one? Next one. So 20th question. Identify the wrong statement in the following. Atomic radius of element increases as one moves down the first group. If you are moving along the group, atomic size increases. Atomic size means radius. Clear, no? Atomic radius of elements decreases. Periods. It is also correct. Along the group, atomic radius increases. Across the period, atomic radii decreases. Clear, no? Amongst isoelectronic species, the smaller positive charge on the cation, the smaller the ionic radii. No, this is wrong. If you take charge increases, automatically what will happen, man? Atomic size decreases. Clear, man? So that is the wrong statement. Clear? You have studied already in the periodic table. As the positive charge increases, atomic size decreases. Negative charge increases, atomic size increases. Clear, man? That is. Last question. This is 21. They are asking. During the change of O2 to O2 minus ion, O2 to O2 minus ion means you have to add one electron to the O2. Then the electron adds in which of the following electrons? You already know. Means O2 means how many electrons are there? 16 electrons. Means sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and the next one you will get now for oxygen greater than 14 electron, 2pz is greater than, next one you will get now pi 2px is equal to pi 2py. There are 2 electrons here, 2 electrons. Next pi star 2px is equal to pi star 2py. Up to here how many electrons I have filled? 1, 2, 3, 4, 5, 6, 7. 7 2s are 14. But how many electrons? 16 are there. One electron here, because first of all you have to write one electron, then add another electron, because these two are equal energy orbital. First we have to fill one electron. Remember, always for oxygen there are 2 unpaired electrons present in the pi star orbitals. Now O2 to O2 minus means what you have to do? You have to add one electron to O2, then O2 become a O2 minus. You have to add. If you add electron, in which orbital will be entered? To pi star orbital only. That is only your answer. So 21 option 1 is the correct.